messages. Let's go. Today's main topic is organic chemistry. Now, what is organic chemistry? Well, organic chemistry is broken up into many smaller topics. Some of these topics, you already know it from everyday life. So when I'm explaining organic chemistry, I'm going to start off with something called alkenes. That is what we're going to focus on today. Don't worry. I know most of you all have no idea what an alkene is. That's my job to explain to you. And next week, we're going to be doing something called, look carefully, the spellings are slightly different. This is alkenes. There's one called alkenes, and if the second one is called alkenes. It has the letter E in the place of the A. You can imagine how confusing that can be, especially when you're new to the topic. And when I was going to school, I didn't even realize that there was a difference between alkenes and alkenes. I just thought it was a spelling error. And then alcohols, but I think everybody has a general idea of what an alcohol is, right? Most people, when they hear about alcohols, they think about the alcohol people drink. Now, that is true. That is one type of alcohol. But there are many, many, many different types of alcohol. Some suitable for consumption and some that are very, very unsuitable for consumption. So alcohols is a very broad category. Then we're going to be doing something called alkanoic acids, which probably you never heard about. And if we have time, we're going to be doing something called esters. And then everybody knows number 6, soaps and detergents. Have you all ever wondered how soaps are made or how detergents are made? The same detergents that you use in your washing machine or the soaps that you bathe with. And you ever wondered how they work? Why, when you use soap or why, when you use detergents, why does it clean your clothes or your body? And most people here just use it, but they probably never were bored enough to sit down and ask themselves, how do these things work? And then there's something called cracking, which is part of a factory process. It's a process done in industries and big factories and whatnot. And I'm going to explain all of these things throughout the summer. Do me a favor, guys. Take down all 7 things. These are the major things that we are going to touch on for the summer, if we have enough time. All right, let's move on. The class is being fully recorded, don't worry. And this is the first part of the story, right? Oh, and I worked really hard on this one, so it has voiceover.
Our story begins in the year 1628, when an outlaw from Spain landed in Porto, Spain, Trinidad, to seek his fortune and freedom. His name was Pelagio, a wanted murderer who is on the run.
Right, so our antagonist or protagonist of the story, however you want to view him, right? He is from Spain and he's an outlaw from Spain, and his name is Pelagio. And by the way, I did not make a mistake here. Port or Spain is how you would spell it in Spanish or French or something like that. So Pelagio is a murderer on the run, and he has just landed in Trinidad in the year 1628. And let's see what adventures await him. That's Pelagio. Right? Oh, you didn't get it. Well, that's how he looks, right? So keep an eye out for him. Yeah, or it's French. Sorry, I failed French and Spanish in school. My mistake. All right. So yesterday we introduced something called the periodic table in physics. There are just some basics here. You don't have to take down anything here, by the way. Just listen. For those who have a little background in chemistry, your periodic table is a list of all the elements that are found in the universe so far. And it has, I want you all to ignore the middle section here. I'm going to cross this out, right? I'm going to cross this out. The periodic table has 8 columns. Column 1, column 2, you see it here, 3, 4, 5, 6, 7, and 8, right? There's a good reason that everything is laid out in columns and each column has a value. I want to focus on column 7, right? Look at the elements that are found in column 7. I'm going to circle all of them, right? You want to keep your eyes on these 4 guys here: fluorine, chlorine, bromine, and iodine. What are the elements in group 7 called? There's a particular name for all the elements found in group 7. They have a general name. It starts with the letter H, right? Right, and it's called something called the halogen. So the answer just appeared on the screen. So fluorine, chlorine, bromine, and iodine are all examples of something called halogens. And a lot of the examples that we're going to be doing today will eventually involve the halogens, right? Yesterday in class, right? Well, when I was drawing an atom, right? I told you an atom has shells. How many valence electrons does carbon have? Let me explain what a valence electron is. Yesterday in physics class, I was drawing electrons circling the atom. Valence electrons are electrons on the last shell or the outer shell. You will notice that carbon, take a look here, carbon is in which group? He is in group 4. Anybody in group 4 will have 4 outer electrons or 4 valence electrons. So you'll have 1 here, 1 here, 1 here, and 1 here. I don't care about the inner shell. I'm just talking about the outer shell. And that means anybody in group 5, like if I were to choose nitrogen or phosphorus, they would have 5 electrons on the last shell. But I want you all to concentrate on carbon. Carbon is going to be the hero of the story today. So the answer to this one, how many valence electrons does carbon have, or outer electrons, or electrons on its last or outer shell? The answer is 4. How many H will bond with carbon? Let me explain that, right? And I have a diagram to show this one here. The H that we're talking about here is hydrogen. You see, hydrogen can bond or stick to carbon, right? It's normal for atoms to stick together. How many hydrogens will bond with carbon? The answer will be 4. I know the last one, for people who are new at chemistry, are not going to understand that one, but I haven't explained on the next slide. I have a diagram for you. So here's what I want you all to do, right? The only thing you all have to take down is the thing that I am circling. Take that down and let me know when you are finished. Don't worry if you're still a little confused. I will break it down properly. Let's move on. Right. So this is what a lot of people were asking. Now, don't take down anything yet. Listen, this part is important. Remember, I now said we can take different types of atoms or even same atoms and, how you say, stick them together. Let's say I have 2 sheets of paper. So let's say you go to your copybook and you tear out 2 sheets of paper. If I want to combine or put those 2 pieces of paper together, and it have many different methods, and I could use glue, and I could paste glue on this page and then stick this page on this page. That's one way to stick 2 pages together. Couldn't I also use Scotch tape? I could use a piece of Scotch tape and combine these 2 pieces of paper. Anybody could tell me of a third way to stick 2 pieces of paper together? I already said we could use glue, we could use Scotch tape, and everybody said the other one. We can use staples. We can get a stapler and staple the 2 pieces of paper together. So you all just saw that, hey, there are more than one ways to stick things together. The same concept can be applied to atoms. Whenever you're trying to stick atoms together, nature has three ways. It has one way called ionic bonding. That's one way to stick it together. Another way is covalent bonding. And then there's a third way, metallic bonding. Now, here's the thing. You don't really need to know what ionic bonding is. You don't actually need to know what covalent bonding is or metallic bonding is. You just need to know of them. The type of bonding that we are going to be using today is covalent bonding. You see carbon and hydrogen. Look at it here. The two main atoms that we're going to be dealing with today. C is for carbon and H is for hydrogen. Carbon and hydrogen stick together using covalent bonding. Like I said, you don't need to know how covalent bonding actually works. You just need to know carbon and hydrogen stick together by covalent bonding. I want everyone to take down everything that I just circled, right? You don't need to draw the world's best diagram here. Just draw something, okay? And yes, these are two electrons here. The blue one is from the hydrogen, the red one is from the carbon, right? And I'm going to show you a different way of drawing this after. So this is the hard way to draw carbon sticking to hydrogen. There's a slightly easier way to draw it to show that carbon is covalently bonded to hydrogen. And I will show you that simpler diagram just now. And the simpler one is the one I want you to use for the rest of class. Let me know when you are finished and we will move on. All right. So I want you all to look at the carbon here. You all will notice that the hydrogen is stuck to the carbon over here. It's stuck to the carbon over here. So it comes like you have a piece of glue here, a piece of glue here, glue and glue. How many pieces of glue did we use above? Well, not above, to the right-hand side of the screen. We used 4 pieces of glue, right? Now, this is how I want you to draw it. This is carbon, right? And each piece of glue, put a line. So we need 4 lines. So each line here is a piece of glue. And of course, what is stuck to the carbon using the glue? Hydrogen. Isn't this easier to draw? Instead of drawing the circle and the actual electrons, each stick here is what you call a covalent bond. So this is a covalent bond, better known, well, for you as glue. And carbon always has how much pieces of glue coming out of it? It will always have 4 for organic chemistry. Make sure you understand that. Anytime, and you're going to forget, but I will remind you, carbon will always have 4 pieces of glue coming out of it. If it doesn't have 4, we did something wrong. Tell me something, would this be correct? Instead of putting 1 stick above, like north, east, west, and south, would this be correct? Tell me something, would that be correct? Would this be correct for today's class? Right, the class is divided. Some people obviously are saying yes, and some people are saying no. How much pieces of glue are you seeing here? 1, 2, 3, and 4. This is also correct. The 4 pieces of glue can be rearranged. But the point is, once it has 4 pieces of glue coming out of that carbon, it is correct, right? Look at it. 1, 2, and you have 1 on top here, 3 and 4. It is still correct. Now, the thing about it, we never, ever, ever, ever said, right? So it's instead of hydrogen, we could we could put something else here. Like it doesn't always have to be hydrogen. It could be another element or something. I could probably put oxygen. But the point is, it has 4 bonds coming out of the carbon. And it doesn't matter if it's rearranged different. Nobody said it needed to have 4 hydrogens. Nobody said that. The rule is it must have 4 glue sticks coming out of the carbon, right? And yes, you all need to take down the simpler diagrams, take down this one and take down the other one and put a big tick underneath. Anytime there are not 4 glue sticks coming out of that carbon, we need to check back our work, like we did something wrong, okay? All right. Right. I'm not going to spend, I was going to explain something here, but I will do this a little later on, right? All right, so let's continue with the story. Remember our protagonist or antagonist of the story, his name is Pelagio, and he has come to Trinidad not only as an outlaw, but he has heard a rumor.
Pelagio had heard rumors of a cave filled with gold. The cave was located in the Gaspery Caves, located in the Dragon's Mouth to the northwest of the island. He wasted no time and started to make his way to the caves via the thick and dense forest.
All right, so how much of y'all have been to the Gaspery Caves? And by the way, the Dragon's Mouth, this is a real thing. It's in between Trinidad and Venezuela. All right, so now there's a legend that says that there's a, I'm not too sure how true it is and what. Like I said, I based it on, I mixed up with my own ideas. So apparently Pelagio is going to try to find this rumored treasure chest or pile of gold in the Gaspery Caves. Do you think it's going to be a straightforward quest? Do you think he's just going to walk into the Gaspery Caves and get his goal and walk back out? Or do you think some drama is going to unfold? I think it's going to be a lot of drama, real drama, right? Let's go. All right, so now I'm going to actually tell you, right, what an organic compound is, right? At the end of the day, right, if the examiner in CXC asks you to define or explain in one sentence, and this is a very popular question, what an organic compound is, well, an organic compound is any member of a large class of chemical compounds whose molecules contain carbon. So once the molecule has carbon in it, it's called organic. So I know some of you are saying, okay, why is carbon so important? Why does carbon get its own category in chemistry? What's so special about carbon? Well, for many different reasons, and on the next slide, you're going to see why carbon is so important. In fact, we are basically carbon creatures, right? Our DNA and whatnot and has a lot of carbon in it. So a lot of scientists, when they're looking for life on other planets, right? They usually look for signs of organic compounds because organic compounds usually, once something has carbon in it and it's bonded in a certain way, there is a chance that that could be a sign of life. Now, life is not the only thing associated with organic chemistry, right? However, there are some exceptions. Not everything, not every single thing on the planet or the universe that has carbon in it, you get to call it an organic compound. Things like carbides and carbonates and carbon oxides are not considered organic compounds. And in case you don't know what a carbon oxide is, everybody knows what carbon dioxide is. CO2, that's carbon dioxide, right? Carbon dioxide, while it has carbon in it, we don't actually consider it organic. Carbonates, things like calcium carbonate, which is very popular in your school labs, even though it has carbon in it, carbonate has carbon in it, carbonates are not considered organic. Most people don't know what a carbide is, so I got some examples here. Calcium carbide, Ca carbon 2, or silicon carbide, SiC. These two have carbon in it. These capital C is for carbon. They are not considered organic. Almost anything else on the planet is considered organic. Take down everything on the screen. Well, not the bubble, when the monster is talking, all right? And learn off that definition for the examiner. They like to ask you that question for one measly mark in the exam. So let's see some examples of organic compounds that can be found in everyday life. Do any of these things sound familiar? I mean, other than the human body and animals and plants are organic structures. But you're talking about everyday things you could go and buy in the grocery. Asphalt, candles, coal, detergents, gasoline, alcohols, DNA, which is found in all living things. Proteins, when you're eating food and you're trying to get protein to get muscles, you eat carbohydrates to get what? Like flour and sugar. Those have carbohydrates, mothballs, paint, paper, plastics. Every piece of plastic in your house is considered an organic compound. That means plastic has carbon in it. Here, what to do. You don't have to take down all. You choose any 5. Take down any 5 examples of organic compounds. I'm going to give you all a half a minute. You take down any 5 you feel to take down, right? All right, so you all have this list already, right? We're going to start off with alkenes today, a category of organic compounds called alkenes. However, you need to take down this table. Everyone write down this table. It's not going to make any sense. You see, there are many different types of organic compounds, and I mean thousands of them, right? And we have to be able to name them. So I'm going to show you all how to name organic compounds, but we're going to concentrate on alkenes. Take down the table, and I will explain how to use the table after you take it down, right? Let me know as usual when you are finished. Right? 1 second, guys. Right. So what is a prefix? Does pre mean before or after? Take go back to your how you call it? English class. Pre means before. So whenever we are naming alkenes, right? Or naming organic structures, right? We're going to have to count how many carbon atoms it has. So in other words, if I ask you to name a structure and it has 5, let's say if it has 5 carbon atoms, and you're going to have to physically count up how much carbon it has, its name will start with what? Pent. It will be pent something. Don't worry, I'll tell you how to write the something. If it has 8 carbons in it, its name will start with oct. So it will be oct something. Don't worry, it's going to be super, super easy after a few examples. So let's move on. Let's move on. You're gonna be able to use it just now, right? Oh, we're good. We have a little break over here. Not a little break, a little continuation of the story. So the story starts with Pelagio again. He's journeying to the caves now.
Pelagio trekked through the dense forest for days. Lonely, hungry, and afraid, he kept telling himself he would soon be rich. Then one night, close to a clearing, he heard a bubbling cauldron and a spirit chanting strange words.
Oh, this can't be good. A bubbling cauldron and a spirit chanting words. Sounds like the perfect thing to walk towards. All right, so we'll see what happens here. So take down the main topic now, alkanes. Alkenes. Well, I guess everyone figured out that we are doing alkenes now, right? Right. Here's the thing. You have a little bit of maths involved in this. You see, when we are drawing or representing organic compounds, it have four wheels. We could use something called the molecular formula, something called the empirical formula, something called the full structural formula, and shortened structural formula. I know you're scratching your head. You have no idea what those things are. It's my job to explain it. But let's explain the maths. It has a formula. Just like how to find the area of a rectangle is length by breadth, there's a formula. Alkenes have a certain formula, and it always follows that formula. Let me write it back big here. Cn, I'm writing back the same thing here. H2n plus 2. Right. If I come and tell you I have C5, so I replace this letter N with 5. This means it has 5 carbons. So that is what I'm trying to say. The organic compound I am talking about has 5 carbons. Could you all use this formula to calculate the amount of hydrogens I would need to combine with 5 carbons? Alkanes always follow this formula, H2n plus 2. Now you have to use the formula here as a maths formula. All you have to do is go and replace. Remember, I just told you N was 5. Look at it here. We are pretending the letter N is 5. So we have to go to this formula now and replace the letter N with 5 and do our calculations. For those who are a little bit confused, remember it's 2n, that's 2 multiplied by n plus 2. So you have 2 multiplied by n plus 2. 2 by 5 is 10. 10 plus 2 is 12. So it's H12. So for an alkene who has 5 carbons, he will always have how much hydrogens? 12 hydrogens. So once I give you the number of carbons, you can calculate the equivalent amount of hydrogens. Try one more for me. If I have C3, calculate how much hydrogens I would need to combine with 3 carbons. Go back and do the calculations. You say 2 multiplied by what? 3, and then add that answer to 2. It's a basic maths formula. You're going to get 8, right? You can do that in your head, right? 2 by 3 plus 2, right? 2 by 3 is 6. 6 plus 2 is 8. Right? So all alkenes will follow this formula. It's called the general formula of an alkene. I know most of you all need more practice on this. Don't worry, don't worry. I'm a person who repeats myself over and over. But I think if I use a slightly different scenario or setting to explain the same thing, everyone will catch it. Do me a favor. Take down everything that I am circling here. Right? And you can take down these 2 examples if you want. Right? You can take down this and this. I'm going to explain all of them. Don't worry, guys. I'm going to explain all of them. Just be patient and you will get a total explanation. N just means the amount of carbon. Like I will tell you how much carbons it has. N is just the amount of carbons. Like over here, the amount of carbons is 5. So N is 5. In the second example, N is 3. That's the amount of carbons N has. I thought it was this slide, but it's ready the next slide. Right. So here we're going to learn to name some alkanes first. Let's just learn to name them. That's the first step. I have three alkenes on the screen. Now, the first thing I want you to know, how do you know something is an alkene? Well, the easiest way to identify this thing called an alkene, it only has carbon and hydrogens in it. Look at all three examples here. This one, this one, this one. All of them only have what? Carbon and hydrogen. You're not really seeing anything else. But I get that's one way to kind of know if something is an alkane. It's not the best way, but it's one way that gives you an idea. Also, you will notice that the carbon, all of them, like if I choose any carbon, look carefully here. If I choose this carbon, how much sticks of glue come out? 1, 2, 3, 4. Remember we said the carbon is always supposed to have how much sticks of glue coming out? 4. What about this one? If I choose this carbon here, does it have 4 sticks of glue coming out? 1, 2, 3, 4. If I choose the middle one, does the middle one have 4 sticks of glue? Yeah. 1, 2, 3, 4. All of them, no matter which carbon I choose, once you pretend that you are that carbon, you will always realize that there are 4 sticks of glue coming out. Also, all these bonds are single bonds. Look at him. He's separated from him. He's separated from him. Do you all see any carbons like this? 1 here, 2 here. It still have 4. Do you see any double bonds anywhere? In any of these diagrams, double bonds are when 2 sticks of glue are right next to each other. The answer is no. Alkenes only have single bonds. There are no double bonds or even triple bonds. There are instances, but they took this off the syllabus, where the carbon has 3 sticks of glue attached to it in one shot. Okay? Alkenes only have single bonds. And all of them follow this formula. And I'm going to prove all of this to you just now. But let's begin to name these alkanes. All alkanes end with the word ane. All of them, A-N-E. The first alkane has how much carbons? How much carbons does it have? 1, and no, guys, somebody said 4. I'm asking how much carbons it has. And it only has 1 carbon. I'm not asking about the sticks of glue. I'm asking how much C's it have. 1. Anything that has 1 carbon, its name will start with what? Meth. So his name will start with meth because he has 1 carbon and all carbons end with A-N-E. You don't have to put the underline part. So his name is methane. The second example, how much carbons does it have? 2. Look at it. 1, 2. So go to the chart. Anything with 2 carbons must start with F, E-T-H. So his name will be F. And all alkenes end with A-N-E. Do you all think you all can name the third alkane for me? What's the name of the third alkane? Somebody said butane by mistake. Count up how much carbons it has. It only has 1, 2, 3. Go to your chart. 3 is what? Prop. P-R-O-P. So its name will start with prop, and it's an alkane, so it ends with A-N-E. All right? Take down yes, draw the diagrams and put the names underneath, please. So that's how you name alkanes. And alkanes only have single bonds. There are no double bonds or triple bonds. Ask yourself, does methane follow this formula? Let's see if this methane follows this formula. Remember, the formula is what? CnH2n plus 2. What number am I replacing the letter N with for methane? What number, sorry? Right, remember N represents the amount of carbons. Methane only has one carbon. So here's C1. Well, whenever you don't put a number here, it's automatically 1, but I'm going to put it 1, right? H, if you replace this N with 1, 2 multiplied by 1 plus 2. 2 by 1 is 2. 2 plus 2 is 4. Look at this now. This is saying that methane, according to the formula, methane is supposed to have 1 carbon and we calculated 4 hydrogens. Is this true? Does our diagram really have 1 carbon and 4 hydrogens? Yes. So the formula does work. What about propane? Is the formula true for propane? Let's go back. CnH2n plus 2, right? Propane has how much carbons? 3. So we're going to pretend the letter N is 3. See? 3. So we have to say 2n, 2 multiplied by 3 plus 2. 2 multiplied by 3 is 6. 6 plus 2 is 8. Does propane really have 8 hydrogens? Let's count it up. 1, 2, 3, 4, 5, 6, 7, and 8. The formula works. All right? The formula works. Right? So you can't really do this unless they give you the amount of carbons. They have to tell you the amount of carbons. They could tell you or draw the amount of carbons. And then you could see for yourself that the formula actually works for it. Right? You don't need to take down the calculations. That's just me showing you. Right? Right. So I just want to do a few things here. I just need to clear the screen, right? I just need to clear the screen here. I'm just clearing the screen. Remember, we now said this was, oops, sorry. We now said this was C1H4. Well, when it's 1, you don't have to write the 1. You could if you want to, but you don't have to. This one here is C2H how much? 1, 2, 3, 4, 6. And we said this was C3 what? H8. Okay? Right. You see these things here? These things here are called your molecular formula. Your molecular formula tells you how much carbons it has and how much what? Hydrogens it has. You see the diagrams underneath? You see how we draw it out, right? When you draw out the carbons connected to the hydrogens, like you show all the glue sticks, you call this the full structural formula. If you look back at your notes, you had something like this. Which one do you all prefer in the exam? Which one would, what would be your method, preferred method for representing an alkane? Do you prefer to write the molecular formulas, or would you prefer to draw out the full structural formula? And do you have a preference? Right? Well, the reason I'm asking you, right? One has an advantage over the other, right? The advantage of the molecular formula is that it's just easier to write. It will save time in the exam. But the full structural formula is a diagram. Won't that take more time to write in your books? However, I'm a fan of the full structural formula because the full structural formula has more information. You can see all the actual glue sticks. And to me, when you actually see all the actual glue sticks and you see how the carbon is physically connected to the hydrogen, for me, it makes it easier to do any calculations. But that's just me. I like to draw. Some people don't like to draw. Okay? Right. So do me a favor now. Put these down and label it what? Molecular formula, and make a note. The full drawings are called what? The full structural formula. And then I'm going to ask you a question based on a note you took 2 slides down. Go back in your notes, right? That's about a couple of pages now. I told you all that there were 4 ways to represent an alkane, but an organic compound. I just gave you 2, molecular formula and full structural formula. Which 2 are missing? Which 2 are missing? I didn't, right? One is the empirical formula and the shortened molecular formula, right? The shortened molecular formula. So let me show you what the empirical formula is. So let's do some empirical formulas, right? I'm going to write the empirical formulas in green. Look at the middle one, C2H6. You see these 2 values here, the 2, let me get a different color, let me get yellow, right? Can this be reduced? Can 2 and 6 be reduced? Remember when I was asking you if you could reduce fractions? What can 2 and 6 be reduced to? 1 and 3, okay? So you say 2 into 2 is 1, 2 into 6 is 3. So you get C1H3. Whenever you reduce it, like whenever you see an opportunity to reduce the numbers, you just call it the empirical, empirical formula. Sorry if I spelled it wrong, but my mind a little bit, I see, clouded right now. Right? So whenever you decide to reduce the 2 values, you call it the empirical formula. Is it possible, you only work with whole numbers, huh? Is it possible to reduce the third one? C3H8. Nah, you can't reduce that one, right? So whenever you can't reduce it, the molecular formula is the same as the empirical formula. So if it cannot be reduced, the molecular formula and the empirical formula are the same. Can the first one be reduced? C1H4. Is it possible to reduce that one? No, because 1 into 1 is 1 and 1 into 4 is 4. So in this case here, the molecular formula is the empirical formula also. Now, I dislike the empirical formula. I have a natural hatred for it. Let me explain why. Let's remember, look at the second example, C2H6. C2H6 tells you exactly how much carbon it has and exactly how much hydrogen it has. But let's say somebody now joins class and I give them the empirical formula. Would they be able, I mean, if they didn't have this diagram, would they be able to backtrack how much carbon and hydrogen it originally had? No, because all you know is that for every 1 carbon, it have 3 hydrogens. So it could be C2H6, but it could be C4H12. All of those, if you reduce it, you will get 1 to 3, right? That's why I don't like the empirical formula. It hides the real values of what it could have been before we reduced it. All right, but just deal with it. You don't have to take down any notes here. You don't have to take down any notes here. In the exam, they will specify whether they want the empirical formula, molecular formula, full structural formula, They will specify. And if they don't specify, my advice is to either use the molecular formula or the full structural formula. That's just my advice. Which one is missing now? We did molecular formula. We did full structural formula. I just showed you empirical formula, the one I hate. Which one is missing? Shorten structural formula. Don't worry, you're going to like this one, right? The shorten structural formula. Let me write it here. Well, I'll write it in after. The shortened structural formula is when you really don't want to draw it, but you want plenty information still. Tell me if this makes sense. This one here is easy. This one is CH4, right? One carbon, one H4. Fine. The shortened structural formula doesn't really help. But look at this one. This one has two carbons, right? I want you to break it up into two pieces. This first carbon has how much hydrogens? 1, 2, 3. And then it has a bond in the middle. And then another carbon with how much? 1, 2, 3, right? Look how I'm going to draw it. CH3, that's this first half here. It have a bond in the middle. And then it have a next what? CH3. That's the shortened structural formula. Not too bad, right? But you have to put a little dash in the middle now. You have to put a little dash, right? That dash is this dash over here in the middle. Let's draw the shortened structural formula for the third one. Let's break it up into three parts. 1, 2, 3. C, and how much hydrogens it has? 3. Dash. This carbon has how much hydrogens? It only has what? 2. Dash. And this carbon has how much? 3. Easy, right? The shortened structural formula. It must be a dash. No other symbol. It must be a dash. Right? Right. Right now, some people leave all the dash. I could see some textbooks doing that, right? Like they will put CH3, they will not put the dash, they put CH2. I find this a little confusing. I like my little dashes in between, so you can clearly see what the subsections now, each section clearer. When it all jumbled up too close together and not separated by dashes, it has confused me. So I just put my dash. That is your shortened structural formula, and guys are going to be repeating it right throughout class. So if you didn't catch all properly, if you didn't catch all 4 properly, don't worry, I will do it again, right? Over and over. This is just an introduction. Let's move on, guys. Let's move on. Let's go. Oh, I'm getting tired. Back to our story here. Pelagio. All right, so let's see what's going on with Pelagio here. Remember, he heard a bubbling cauldron.
The spirit introduced herself as the Diabas, the Lajables. She knew why he was here, as many men and women have ventured into the forest to seek the gold in the Gasperi caves. The Lajables offered to tell Pelagio exactly how to find the gold, but for a favor in return.
Oh, well, that's good. It seems that the Lajables wants to help Pelagio to find the gold. But obviously, she's not going to give that gold unless she gets a favor in return. Do you think it's going to be a bad favor, a good favor? What are your thoughts? It might be some, you see, you might jump to the conclusion it's going to be a bad favor, but you're going to be surprised.
Mortal, listen to my story. I've lost something dear to me and my soul cannot rest until it returns to me.
So apparently Lajables has lost something that she cares about very, very much. And she wants Pelagio to get that in return for the gold. Anybody want to take a guess of what the Lajables lost? Somebody said her legs. Her mind, her beauty, a child, a lost love, family member, a cursed object. All right. Somebody said her dog. Oh Lord, a cow heel. All right, let's see. Her blanket. Oh my God. All right. Do you all think you all can work backwards now? I want you all to try to draw pent in. Use this chart and try to figure out. I want you to draw the full structural formula. The full structural formula for pentane. You're drawing. Give it a shot. I know you can't send the drawing on this end, right? But at least let me know when you are finished with your attempt. Now, it is pent in. Pent means what? 5. So we know it has how much? 5 carbons. So we just have to draw 1, 2, 3, 4, 5. That's our starting point, right? It must have 5 carbons. And each carbon is going to be linked by single. Now, each carbon must have how much glue sticks coming out of it, like this carbon here. 1, 2, 3, 4. This carbon have 2 already, 1 on this side, 1 on this side. So you need 1 above, 1 below, 1 above, 1 below, 1 above, 1 below, 1 above, 1 below, and to the left. You notice all the carbons there have single bonds, and all of them have 4 glue sticks coming out of it. What goes at the end of each glue stick for an alkane? Hydrogen. So you put a hydrogen at each end. Right? I'm just using some different colors, so, you know, looks cool. All right. And there you have it, guys. That's a drawing of pentane. That's the full structural formula. Anybody want to tell me what the molecular formula is? What's the molecular formula for alkene? I mean, for pentane. Right? Isn't it going, the molecular formula, it's going to be C5. You're going to replace N with 5, the amount of carbons, 1, 2, 3, 4, 5. To calculate the hydrogen, is say 2 by 5. So 2 by 5 is what? 10. 10 plus 2 is 12. Can you reduce this particular molecular formula to get an empirical formula? Can you reduce 5 and 12? No. So in this case here, the molecular formula and the empirical formula is exactly the same. Yeah, you can't really reduce it. And what about the shortened structural formula? And we could break this up into 1, 2, 3, 4, 5. This carbon has 3 hydrogens. The ones in the middle, the carbon only has 2 hydrogens. And the one at the end has what? 3. So I can write it back like this. CH3 dash CH2 dash another CH2, another CH2, and the last one has CH3. Always put the carbon first and then the amount of hydrogens. Carbon and then the amount of hydrogens. Right? This is the shortened, well, when you write it like this is the shortened form, the shortened structural form. The one on top is the full structural form. The full is the hardest one to draw, or the longest one to draw. You think y'all can get this correct in the exam? A question like this is worth about 4 marks in the exam, 3 to 4 marks. And you're going to get so much practice today, so much. Right? Somebody said only 4. 4 is plenty. All right, guys. So here we have all the answers for pentane, full structural formula, molecular formula, and the shortened structural formula. All right, let's move on. Right. Let's just get the practice now. You think you all could do this for me? Octane, I want you all to do all 4. I want you to draw it, full structural formula. I want you to do shortened structural formula. molecular formula, and if possible, if it could be reduced, the empirical formula. 2 minutes, right? Send what you could send, and whatever you can't send, like drawings, obviously don't send. Good luck, guys. I'm pausing the recording here. So octane has, well, when you hear oct, like an octopus, you know oct means 8. You can even see it on the chart here, 8. Now this is going to be a little problem. I need the whole screen to draw this, right? 1, 2, 3, 4, 5, 6, 7, 8. Let's get those bonds going. 1, 2, 3, in between. And each one has 1, 2, 3. The ends will have 3 coming out at the, on the left and right hand side. And the middle ones, you just have to put in an extra 2 on top and underneath, right? Hopefully the examiner will give you enough space, right? In some exams, you just barely have enough space to make it fit on the paper, right? And at the end of each bond, right, you put your hydrogens. Oh, this is a long while to draw. Right, how much people had that? It looks like ketchup and mustard. Right. Let's get the molecular formula. Remember, the amount of carbons is 8. Clearly, oct means 8. So it's C8. Put it in the formula. We're pretending N is 8. 2 by 8 is 16. 2 multiplied by 8 is 16 plus 2 is 18. That's your molecular formula. Can that be reduced to the empirical formula? Yeah, this one could be reduced, and 2 could go into 8 and 2 could go into 9. So that one could be reduced. Somebody told me just now it could not be reduced. That's not true. 2 could go into in both of them. So that's C2H9. So the yellow one, C2H9, is the empirical formula. And unfortunately now, oh God, I getting tired of so much drawing. I have to draw the shortened structural formula. Well, let me just get to it, right? And I'm gonna, it will have 6 in the middle, right? So it's, this one has 3, the one at the end has 3, and then the ones in the middle, it only has 2 hydrogens. So it's CH, oh Lord, boy. CH3 plus, not plus, sorry, I told somebody you're not supposed to use a plus, you're supposed to use a little dash. CH2, CH2, CH2. Oh Lord, so repetitive. Boy. And the last one is CH3. Right now, a few people are disagreeing with me, and I think it's because of the maths. For the empirical, can 2, 9 be reduced anymore? Because I real sure 4 can't go into 18. Eh? Remember, the molecular formula is 8, 18. Will we establish this is correct? I don't think we could divide both by 4. I'm real sure 4 can go into 18, well, flush. The only way we can reduce that is 2 over 9. I'm real sure. All right, I'm real sure. Right. Oh, no, guys, the person, oh my God. The person who corrected me, I apologize. I was wrong. And I telling him man he wrong and all kind of thing, you know. Thank you to the person. Thank you. 2 into 8 is 4. My mistake, guys. Oh my God. I guess. I don't even know what to say yet. All right, mistake alert, people. 2 into 8 was 4. I corrected it here, right? For the empirical formula. Made a mistake alert. All right, so that's on the recording in case anybody looks back at the record. All right, so this one here, that's a quick practice. What's the name of this? Now we did molecular formula, empirical formula, and shortened. What's the name of this alkene on the screen here, by the way? Well, what's the name of it? That's hexane, right? Now I already drew it out. So you have the full structural formula. So I already have the full structural formula. And we now say this is what? Hexane. Just one last practice. Could you all quickly write the molecular formula, empirical formula, and draw the shortened structural formula? Or write the shortened structural formula. It's hexane, just in case somebody missed it. It has 6 carbons. 1, 2, 3, 4, 5, 6. 6 is hex. Right, so all 3 quickly, and we will move. All right, the molecular formula is easy. It has 6 carbons, so it's C6. 2 by 6 is 12. 12 plus 2 is 14. Can 6 and 14 be reduced? 2 could go into 6 and 2 could go into 14. So you get 3, 7. And then the shortened structural formula, right? You break it up into parts. Should be easy. Right, you go have 4 of them in the middle. And on the end, CH3. Now, based on the answers I'm seeing, I'm pretty much sure the majority of the class has caught on and they understand how to name and represent alkenes. Okay. All right, so let's talk about the larger bless. So she's going to tell Pelagio her story and what she lost. All right, so pay attention. This is where it gets a little bit spooky.
The Lajables had arrived in Trinidad in the year 1530. Her birth name was Isabella, and she had a child named Fernandez. However, on his 7th birthday, Fernandez disappeared. One villager said he was playing too close to the forest when she saw a short shadow appear, possessed him and led him into the forest. The villager screamed and ran for help, but was too late. He was gone.
What do you think took Fernandez? Well, what do you know from Trinidad folklore that takes children? It's either a dwen or, well, some people say a buck, right?
This was many years ago, and I know now it was the Duensutu team.
It was the Dwens. All right. And that's the Dwen there, right? And this is Fernandez to the left-hand side of the screen. He's going to get possessed. Poor Fernandez.
Almost 100 years has passed, and she explains that Duins do not die like humans. Their flesh may leave the earth, but their souls and memories remain and roam the forest. The animals and trees of the forest have told her that Fernandez's spirit briefly appears close to the Gaspery Caves at sunrise every day.
So you all see the connection now, right? Her son's spirit is very close or just outside the Gaspery Caves. Exactly where Pelagio is headed. All right.
I want you to bring what's left of my son back to me. I would go myself, but he can only exist in the night.
So the larger bless can only exist in the night. So she can't actually do it herself. So she needs Pelagio to do this task for her. What do you all think about Pelagio? You think he's going to be a good person, a bad person? He's going to be the hero of the story, right? Well, that's Fernandez there with his little hat there. All right. Now we are going to do something called branched alkanes. Look at all the examples that we did today. All the carbons were lined up one after the other, like a train. A branched alkene, look at this, right? You notice all of them form a line here. But you notice it have a branch coming out here, like how a branch comes out of a tree. This is called a branched alkene, where all the carbons do not form a straight line. Naming it is going to be a little bit different. It's a little bit tricky, but I should be able to get through this. Do me a favor. Take down everything here, right? This here is not going to make sense. And this is the diagram of the branch alkene that we are going to have to name. Take down everything, let me know when you're finished, and I will explain it very, very slowly. Recording here. I am pretty sure this is an alkane because look at all the carbons. It only has single bonds coming out of them. Look at any carbon. It only has single bonds coming out of them. So it is an alkane. How do you name an alkane? You actually, right, kind of name it backwards, right? You kind of name it backwards. You are going to start with the red part first, then do this, and then do this part too. So you kind of work backwards. Here's what you do. You all will see a main branch. Do we all agree this is the main branch or the trunk of the tree? Well, let me call it. Is this the trunk of the tree? That's the trunk of the tree. And which one is the branch? Isn't the branch the blue part I am circling? Everybody can agree with that? Let's make sure. The pink is the trunk or the main part, and the branch is the little carbon coming out on the side. The red part is for the main part. Let's see if I can color code it. Prefix means before. The main branch, how much carbons, according to the main branch, I'm going to change it to the trunk. The trunk of the tree has how much carbons? The main part. 1, 2, 3, 4, 5. So what do you think we should name the red part? It should start with pent, right? Pent is what? 5. And we have to end it with ene. So the red part is pentene. So the first part is to name the trunk of the alkane. The next blue part is for the branch, prefix of branch. Let's go to the branch. Now, this whole thing is not the branch, just the part we circle. The branch has how much carbons? Ask yourself. The branch alone has 1 carbon. You all seen it here, right? 1 is meth. Okay? I'm going to use yellow though, because the blue won't show on blue, right? The branch does always end with YL. So the blue part will be meth because it has 1 carbon, and because it's a branch, it ends with YL, always. Then put a dash here. What does the C represent? The C represents on which carbon does the branch come off of. Now, you have 2 ways. You have to find the shortest way to reach the branch. If I start to walk from the left-hand side, isn't this the first carbon? Isn't this the second carbon? Isn't this the third carbon? And isn't this the fourth carbon? Doesn't the branch come off the fourth carbon? Everybody seeing that? The branch is coming off the 4th carbon on the tree trunk. So you might be tempted to put what? 4. But that is actually the wrong answer. Remember, there are 2 ways to reach the branch. You can walk from the left-hand side, or you could walk from the right-hand side. If I start to walk from the right-hand side, this is the first carbon, and this is what? The second carbon. We just always have to choose the shorter way to reach the branch. The correct answer is 2. Because if we walk from the right-hand side, the branch comes off the second carbon. So you have to put 2. If you put 4, it is wrong. Okay? I know this is your first example. Some of you all catch it and some of you all didn't. That is all right. Take down my answer. And how about we try 2 more so everybody gets it? If you walk the longer way, you will get it wrong in the exam. Take down what's on the screen and we're going to try a couple more. Don't worry, everybody is going to get it. All right, let's try another example. Let's try this one. Let's try this one. Everyone draw this diagram for me, and we're going to take our time, break it down again into the trunk of the tree and the branch of the tree. And we're going to try to name it again, right? All right. Let's identify the main branch. This here is the main branch. Everybody agree? No, I keep saying the main branch. I mean the trunk of the tree, the main part of the tree. And isn't this the branch coming off the trunk? Everybody with me so far? Let's just make sure we have that part down, right? Right. Right. So we're going to do the red part first. The trunk. The trunk has how much carbons? 1, 2, 3, 4, 5, 6. 6 is what? Hex. And so we put hex plus the ene part. So the red part is hex E. That's the trunk. The branch now has how much carbons? Once again, the branch only has 1 carbon. So the prefix of the branch is going to be what? Meth. But all branches end with YL. It ends with YL. So it's meth YL. By the way, there's no space between the L and the H. It's one word. Methylhexane. One word. No spaces. Now ask yourself, where does the branch come off? If we walk from this way, here's the first carbon and here's the second carbon, right? Doesn't the branch come off the second carbon? So for C, we put 2 and a dash. This means that the branch came off the second carbon. Now we chose the correct number because if we walk the other way, here will be the first carbon, second, third, fourth, and fifth. If we walk from the left, it comes off the second carbon. If we walk from the right, it comes off the fifth carbon. You always have to choose the smaller number or the shorter way to reach the branch. Always, 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 always. If you choose the longer way, just to answer the questions, the answer is you will get it wrong. So if I put 5 instead of the 2, it's wrong in the exam, right? And this is how you write the answer. 2 dash, you do not have to put the number sign. C, tic-tac-toe means the number the C comes off of, the branch comes off of. So this is the actual answer. 2-methylhexane. You understand it a little bit better now? We have another example, don't worry. This question in front of us has how many branches? It only has 1 branch, right? And the 1 branch is the blue part that I circle. It could have more than 1 branches, right? Like it could have 2 different branches, but they removed that from the syllabus. you only have to deal with a single branch. Lucky for you, right? Let's move on to another example. You all notice, for this example, did I draw the full structural formula or did I use the shortened structural formula? Which one did I use? Because the examiner doesn't have to draw it all the way out there. You think you all can name this one for me, right? See if you can name this one. Let's look for the main branch, the main trunk. Everybody agrees that this pink part is the main part, the trunk of the tree. The trunk of the tree has how much carbons? 1, 2, 3, 4, 5, 6. So the red part is for the trunk of the tree. So we know the trunk is hex, and it always ends with E. Great. Real people had that. The next part gave some trouble. Which one is the branch? Is the branch this or do we have to include? I'm gonna get a different color. Is the branch the green or the blue? Which one is the branch? The green or the blue? Right, not the green, eh? The branch is the piece coming off the trunk. This first C here is not part of the branch. He's part of the trunk. So this blue part here is the branch, right? I see some people thought that the C above was also part. That's not part of it. So the branch has how much C's? It has 2 C's. 2 is what? F. So it's F, and all branches end with what? YL. Is there a space between the L and the H? No, you're not supposed to have a space. Now put a dash. Where does the branch come off the main trunk? If we walk from this way, this is the first carbon, second carbon, third carbon, fourth, and fifth. So you might think it's okay to put 5. But remember, we have to choose the shorter way to walk to the branch. And if we walk from the right-hand side, this could be the first carbon, and this could be the second carbon. Doesn't the branch really come off the second branch? We always have to choose the shorter route or path to reach the branch. So some people had 5, but it's supposed to be 2. Once again, if you choose the longer path and put 5, it's wrong. There's no such thing as you could also do that. No, that's not. Now, we had a question. Suppose the branch was exactly in the middle. And if you walk from the left or walk from the right, it would be the same amount of carbons. Well, in that case, it doesn't matter which side you choose, because either side is giving you the same exact answer, right? Right. For those who got it wrong, you think you at least saw your mistake. A lot of people got it correct first chance, right? Right? Now, it's not meth because the branch has 2 carbons. 2 is F. The branch has 2. If it had 1 carbon, then it would have been meth. Let's move on. All right, back to our story here. So the larger bless has told Pelagio about her plight, right? Let's see what's going on here.
The spirit tells Pelagio that the Duins will only set the soul of her son free if a human gives them half the gold within the caves. The Lajables makes Pelagio promise to give up half.
All right, what do you all think about that promise? Remember, the larger bless is telling Pelagio exactly where to find that gold. But when he comes out of that cave and sees the Duins, he has to give up half in exchange for his son. All right. I don't know if you're all doubting poor Pelagio.
I promise. Now tell me where this vault is.
These accents.
Be warned, mortal, I am not to be deceived.
All right, she's not to be deceived, and Pelagio made a promise. A wanted murderer.
As Pelagio journeyed through the forest, he could swear he heard the animals and trees whispering to him. He could hear voices, but could not make sense of it. He ignored it and concentrated on the gold.
What do you all think the trees and animals are trying to tell him? All right. All right. So now we're going to turn to something called an isomer. All right. So I don't think we're going to make it to the end of the story today, guys, because we're only halfway through the story and we only have a few more minutes left.